This is the third video over Chapter 8. We're going to cover the appendicular skeleton. Please note that we are not going to cover all of the bone markings in this particular video. You will cover all of the bone markings in the laboratory portion of this course. What we will briefly go over is the pectoral girdles, pelvic girdles, and your upper and lower limbs. Looking at your pectoral girdle, that is composed of the clavicle and the scapula. When we look at these joints, keep in mind the names of the joints typically are the names of the bones put together or the bone markings. So if we look at the sternoclavicular joint, it is right up here between the clavicle and the manubrium of your sternum. The acromioclavicular joint is between the acromion process of the scapula and your clavicle. Glenohumeral joint is the glenoid cavity of the scapula and the head of your humerus, a nice ball and socket joint. Let's start going over your bones. The clavicle is a nice S-shaped bone. The medial end is up against your sternum. The acromial or lateral end articulates with the acromion process of your scapula. Usually the fracture site is right where the two curves come together. This is going to be stabilized by a number of ligaments. The scapula is a nice triangular bone that you find in the upper back region. The scapular spine ends with the acromion, and this articulates with your clavicle. The glenoid cavity is where the head of the humerus articulates, and that's your ball and socket joints. Above the spine, supraspinous, and below the spine, infraspinous, those two fossas will have two of your rotator cuff muscles in it. If we look at the humerus at the proximal end, you have the head, which articulates with the glenoid cavity of the scapula, and you have the anatomical neck right next to it. You have two large processes called tubercles, the greater and lesser tubercles for muscle attachments. In between the tubercles, you have the intertubercular sulcus, and this is where your pectoralis major and your latissimus dorsi inserts. The surgical neck is a typical place where you have fractures. And then on the lateral side of the humerus, you have the deltoid tuberosity where the deltoid muscle inserts. When we look at the distal end of the humerus, you have the radius on the lateral side and the ulna on the medial side, and that forms your elbow with your humerus. The head of the radius articulates with the capitulum of the humerus, this nice rounded area. Your ulna articulates with the trochlea. The part of the ulna that articulates with the trochlea is called the trochlear notch. On the posterior surface of your humerus, you have a depression called the olecranon fossa, and that is a depression for the olecranon process of the ulna inserts when your arm is fully extended. On the sides here are the epicondyles. The large one here is the medial epicondyle. Your ulnar nerve runs through a groove here, and so we call that the funny bone. When we look at your forearm bones, you have the radius on the lateral side, you have the ulna on the medial side. They articulate with each other proximally and distally. Proximally, the head of the radius articulates with the radial notch of the ulna, and then distally, the head of the ulna articulates with the ulna notch of your radius. You will have an interosseous membrane in between those, kind of holding it, but still allows movement. Remember, between your forearm bones, you will have pronation and supination. So when you pronate, it is your radius that is going to do the movement, and it circles around your ulna. When we look at your hand, you have the carpals, these are your wrist bones, the metacarpals, and the phalanges. When we look at your wrist, there are 8 carpal bones. The most important ones are going to be in blue. Your wrist is primarily the radius articulating with the scaphoid and lunate. You have a condylar joint here. On the distal row, the most important bone is the trapezium. It articulates with your first metacarpal. This is a saddle joint. Your metacarpals are numbered 1 through 5. The first one is going to be towards your thumb, so this is the most lateral. Your knuckles are where you have the articulation between the metacarpals and your phalanges. The phalanges, you have 14 on each hand. Each one is called a phalanx. On your fingers, you have 3 of them, proximal, middle, and distal. Your thumb only has 2 of them, proximal and distal. The thumb is called the pollex. Now let's look at the bony pelvis. If we use the term bony pelvis, we are looking at the 2 coxal bones. We're looking at the sacrum and the coccyx. So it is a combination of appendicular and axial skeleton. If we're looking at pelvic girdle, it is the 2 coxal bones coming together and joining in the front. This is a joint, the pubic symphysis. You need to know the difference between the pelvic girdles with males and females. Males have a much heavier pelvic girdle. The females are a little bit lighter and they're wider. This is adapted for pregnancy and childbirth. If we look at the pubic arch, you notice on a female it is very wide, whereas on a male the pubic arch is quite narrow. When we look at the actual bone from the inferior, you can see it's much wider in a female, much narrower in a male. The coxal bone originally was 3 separate bones with growth plates in between. Then they will fuse after growth into 1 bone. Your 3 bones originally was the ilium. This forms your hips, the ischium, where you're sitting on, and the pubis in the anterior region. All 3 bones will fuse together into the acetabulum. This is the socket that the head of the femur articulates with. You will go over all of these bone markings in laboratory. I do want to point out that 2 of these features are going to be important in the next unit when you talk about nerves. So the greater sciatic notch is where the sciatic nerve will run through, and the obturator foramen is where the obturator nerve will run through. The femur is the longest and strongest bone in the body. You have the head that articulates with the acetabulum. The neck is a common fracture site. You have greater and lesser trochanters for muscle attachments. The medial and lateral condyles on the distal end articulates with the tibia. Your patella is a sesamoid bone. Sesamoid bones are unusual in that they develop in a tendon or a ligament, and they're used for leverage. In this case, the patella increases the leverage of the quadriceps femoris tendon. The tibia is a weight-bearing bone. This is where your shin is. And what you feel on the medial side of your ankle is the medial malleolus. It is going to be connected by interosseous membranes with the fibula. The fibula is not going to be part of your knee, but it is a stabilizer. What you feel on the lateral side of your ankle is the lateral malleolus of the fibula. When we look at your foot, You have the tarsals, which is your ankles, the metatarsals, and then the phalanges. There are 7 tarsal bones. The talus is the bone that articulates with the tibia and fibula. The calcaneus is your heel bone. Then you also have the cuboid, navicular, and 3 cuneiforms. Your metatarsals, where your arch of your foot is, you have 5 of those, just like you have 5 metacarpals. Number 1 is going to be medial towards your big toe. The phalanges are going to be similar in number and arrangement to your hand. The big toe is going to be the hallux. This is the end of chapter 8. Make sure that you go back through bones and bone markings in your laboratory portion.